end when the particles actually collide together, and we measure what comes out, and that's what I do. But to get to that point, it's a very complex chain of accelerators and some very smart, talented engineers that help us run everything. The accelerator complex starts in here. There's some intermediate steps here, and then at the end of the day, we have protons and antiprotons co-circulating around this ring. And they circulate around this ring called the Tevatron, which is considered our main experiment here. Essentially, these are magnets, so the beam is flowing inside the beam pipe here, and particles want to go straight, right? These are charged particles, protons and antiprotons. So in order for them to go in a circle, you need a magnet. So if you have a moving charge in a vacuum, this is all under vacuum, there's no air inside, and it needs to go in a circle, you have huge dipole magnets. Oh, sorry, these are dipole magnets, these ones. And those essentially are in charge of bending the protons to make them go in a circle. When you accelerate them up to high energies, Einstein tells us that E equals mc squared. So after a certain time, these particles are traveling at the speed of light. But you're continuing to add energy to them. So if you increase the energy, you increase the effective mass of these particles. At two places, those two beams are brought into contact with each other, and the protons and antiprotons collide together. We look at what comes out. Certain particles appear, certain particles disappear, and that mass gets transferred into a zoo of other particles. The stuff that flies off is stuff that is absolutely crazy. You have particles like muons and taus and other electrons and other protons, and you have bits of light, photons, that are coming out. And you have more exotic particles called like pions and kaons and all these crazy little things. And then you have zoos. Particles are crossing very frequently, like 10 to the 6 times a second. So we have to figure out what events we're interested in and what events we're not interested in. And to do that, we have to read out really quickly whether or not it's an interesting event. If nothing happened in the event, if the two particles pass right through each other, we're not interested. If we get a hard collision and crazy stuff happen, we're interested in keeping that event. When I say keeping it, I mean writing it out to disk. Silicon strip detectors, which are essentially strips of silicon like this, you can see here. And when a particle passes through a strip, there's a little voltage that's generated, and we measure out these little strips on the side. That voltage. In the whole standard model of particle physics, we look at what comes out. We look at this zoo of particles that come out, and we say, what does this tell us about how the world is made?